So what we want to do is to be able to solve equation using the null factor law. Okay, that's what we're looking at. Alright, so we're talking about a null factor law. Now this is kind of, if you understand this principle, the rest becomes a bit easier. If you ignore this and the fact that this is what you're actually doing, the understanding won't be there. Right? Does anyone already know what a null factor is?
I have an idea, but I don't want to say it.
Go on, give it a go.
I feel like it's a factor or something, but it can also is not a factor. So
It's not that it's not a factor.
Yeah,
No.
it can be used as a factor of it, but it's not the factor.
No, I wouldn't be able to give you that. It's not that it's not. It's definitely a factor.
No,
Always.
It's a factor, but even though it's not the factor of a certain number, it can still be used for that number.
Oh!
Does that make sense?
No, not quite.
Okay.
You'll see what I mean when I say what it is.
Okay.
It's a fit.
Is it sort of like a bunch of numbers, like,
It's actually only one number.
or something, and it equals 0?
Oh, okay.
Because I know null is 0, so.
Yes, okay, we've got that. I'm going to write that down. Null. Let's go with 0.
That's what I'm trying to say. It's not that number because it's like nothing. Is it one?
Tentatively. Right, so the null factor. Now, first of all, we need to understand again what factors are. What are they?
Things that
Ella?
So like a factor is like two numbers that multiply to create another number.
Okay, so if I said A times B, right,
Equals
that's
C.
the product of two numbers, okay? Therefore, they are factors of the
C.
result, okay, if you like. So A and
B.
B are factors of C.
Or like another one, it could be like D and E or factors of C.
Yeah, I can change whatever letters I like. Right, can I also, just out of interest, if A and B are factors of C, what can we say about C? Is
Not
A
a prime number. A multiple?
not necessarily a multiple is what I'm looking for. What if it was 1 and 5? Then
Yeah.
5 would be a prime number. So
But I thought it didn't count when it was 1. Like I thought 1 didn't count.
no, what you're looking for is no. You said C will not be a prime number, but if the factors multiply to make,
Okay.
it can still be a prime number. C is a multiple of A and B. Is that okay for everyone? So the link between factors and multiples.
And
Now-
there can be more than one set of factors.
Yeah, exactly. So for
Like a
instance,
faction tree?
something we need to appreciate. By the way, slow me down if you are writing and want me to. Something we need to appreciate. What if I said A times B equals 36? And I asked you for what A and B are. Yep,
It could be 6 and 6.
that's not what I'm thinking.
9 and 4.
That's not what I'm thinking of.
1.
No, 3 and 12.
That's not what I'm thinking of.
Is A 36 divided by
Oh, we could look at it in that way, I guess. Yeah. What I'm trying to get at, go on.
Null times null. No?
No.
Okay. Well,
What I'm trying to get at is how many A's and B's are there?
1 each.
36.
Enough to make 36. Enough sets to make 36.
How many A and B combinations are there?
1.
1.
No.
2. 3.
Well, you've already given me 1 times 36, 9 times 4, 6 times 6,
2 times 3.
12 times 3.
Oh, like with
How many?
possibilities of it being
What if I told you there's an infinite number?
Oh,
yeah,
yeah,
that's
use
No.
Use
decimals.
decimals, fractions, yeah. I could use any number. There are actually an infinite number. So actually, I'll just say what Kiara said, just to show you. is that I could express the factors as factor A can be 36 divided by B. Therefore, B could be anything, and therefore A would be the result. Yeah? So there are an infinite number of possible combinations of A and B. Therefore, if I asked you to solve A times B equals 36, you would say, I can't, because there are an infinite number of solutions. I could limit it by saying A and B are whole numbers, positives. We didn't even consider negative values, but they could be negative. Okay, yeah?
And this is like, I know your question. But is the multiple the number that the factors make?
Yes.
Yeah. So does that mean like a prime number like 5 could have more multiples if they were like not whole numbers? Like
Sorry.
Okay, so what you meant was factors, yeah?
yeah. Because you could do like 2.5.
When we
times 2.
specify actual factors of a number, we only use positive whole numbers. Okay?
But like
But
hypothetically.
I am not necessarily talking about just factors now. I'm asking for two numbers that multiply to make. Did you all get that? Because a lot of people are kind of switched off. Pens being thrown around now means I get to giggle and be silly. Right? Just concentrate. So, important thing here. Ella asked a very good question. A times B could be any numbers, but when I talk about actual factors, factors are whole numbers and positive. So there's a difference. Okay? So a prime number, do you know the definition of a prime number? The correct one? Don't fall into the trap of the incorrect one.
Any number that's divisible only by 1 in itself.
See, I would say that's the incorrect definition of a prime number, but that's the most common one. That's what I was expecting you to say. The reason, go on.
A prime number is a number that only has two factors.
That's the correct definition. Do you know why saying has two factors and not is divisible by itself and 1 is correct? Do you know why, Lynn?
Because 1 isn't a prime number, but it is divisible by 1 in itself, but it doesn't have 2.
Exactly. How many factors does 1 have?
1.
1. That's where the mistake comes from. People think, well, 1's divisible by itself and 1. That's why that definition, although it's very commonly stated, is actually technically incorrect.
Is it okay if you say one set of factors instead of saying 2? Because that's what I was going to say.
No, well,
Say
I could
one
say,
set
actually,
of factors.
no, because factors don't necessarily have to be written as pairs. You work them out as pairs, but a factor, like 3 is a factor of 9, okay? 1 is a factor, 1, 3 and 9 is a set of factors. It doesn't have to be in pairs. Because a square number has an odd number of factors, so it wouldn't. Okay. Anyway, factors. Now, let's get back to this null factor thing. Because this is important. The null factor. Now, what we want is to deal with this situation. We're going to use this piece of information that if A times B happens to equal 0, this situation gives us a piece of information. So, A times B equals 36. I can't tell you what A and B could be. However, if I state A times B is equal to 0, it's a very special case. Because what do I know?
One of the numbers is 0.
One of the numbers has to be 0. So either A equals 0 or B equals 0. And that's because if I multiply two numbers together to get the answer 0, one of them has to be 0. That's the only way for it to work. And it doesn't matter what the other one is. I just know that either A has to be 0 or B has to be 0. Does that make sense? So we're going to use that information. Alright? So, here's how we're going to use it. We're going to solve a quadratic. Okay. So we're going to solve a quadratic using the null factor thing. So a times b equals 0. That's what we're going to do. So if I asked you to solve x squared plus 7x plus 10 equals 0. Right? So I want to solve that. Now what people try and do is they minus 10, put 10 on the other side, then they try and divide by x, and they just make a mess. Because there isn't actually a pen and paper way of solving that. Well, technically true, but I can't just rearrange as it is and get an answer. Alright? Maybe you've tried in the past. But we know how to put this in this form, don't we? Something times something else. How do we do it?
Factors.
So we are looking to factorize. Factors, factorize. So what is it in factorized form?
5 and 2.
So we've got x plus 5, x plus 2, yeah? You all happy with that? Now that is the factorized form of that. It still equals 0. It's the same thing written in a different way. And it just so happens we now have a times, because there's no sign, b equals 0. So what do I know now? Well, I know either x plus 5 has to equal 0, and that will give me an answer of 0, or x plus 2 has to equal 0. Now those two things I can solve. Yes?
Wait, so the whole point of this is to find out what other factor is 0?
No, what I'm doing is I'm using the fact that one of the factors has to be 0.
So how would we use null?
That's what we're doing.
There's no other
This
way
is the null thing. The fact that
So we'll get questions like this and we have to work it out and write like either blah blah.
yeah, so what I'm showing you is when it we'll come back to the first question we did on the board, and I'll explain what we've got to do, and it'll go, oh, all right, sort of makes sense. All right?
Like that.
So what we've got then is, because we've got two factors is equal to 0, we know that either or. So actually that leads us to the fact that there are two possible values of x that I can use, right? What would they be? Well, if x plus 5 makes 0, that means x would have to be
Negative.
negative 5. If x plus 2 is equal to 0, x would be negative 2. So what you'll find out is that if we stuck both of those in here, we would get the answer 0.
But which one would make it?
Both.
So
They are both solutions. I have two solutions to this equation. Okay? This is the important thing. Because if it was equal anything else, I wouldn't be able to do this. Because something times something equaling 10, how many possible answers are there? Infinite. I've said it once. But something times something equaling 0, that I can deal with.
it's only one thing.
Well, there's two in this case.
Well, oh yeah.
Yeah. Rather than infinite, I guess technically there are infinite, because if one's 0,
Yeah,
the other one will be anything, but we don't care. Okay? So let's just check. Let's do a check and say, well, let's use this one. And we'll say it's minus 5 squared plus 7 times minus 5 plus 10. What does it equal? So we've got 25.
Where'd you get that from?
Well, I put this value into here.
Oh.
Okay, so I'm checking that my solution gives me the answer that I need. We should always do that, just in case I made a mistake. So I'm putting minus 5 in for x, putting it there, look. Minus 5 goes in. So 25 minus 35 plus 10 does in fact give me 0, which is what I wanted. Pardon? And I could do the same with negative 2. Okay. You found that satisfying?
It just actually makes sense.
So let me. So there's why we factorise. That whole thing of factorising, that's why we do it. To get it in the form A times B, so that we can then say equals 0 and we can solve it. So I'm going to give you another one like this, and then I'm going to give you one that is considered easier, but everyone makes the mistake and tries to make it hard. So if I ask you, first one, similar to this one, solve x squared minus
Are you going to tell us which
3x.
one is the easier one?
Well, I've just told you this is the harder one. So x squared minus 3x. Let's do minus 10. Right? Equals 0. Yes, Jen?
Did we finish the other question or were we just leaving it?
That's it. That's the two solutions.
Oh.
They are my solutions.
So you can't
Two.
narrow it down? You don't narrow it down?
No, there are two solutions.
Oh. Okay, so that was
It's not like a linear one where there's only one x equals. I have two possible values of x, both of them work.
So like say like a question said to solve it, you would just write x equals minus 5 or...
Exactly. I have to give both solutions.
Okay.
Yes.
I would then look on
A curve, a graph.
yeah.
Good, very, very good question, but we're going to do that next. Not today, but it's a very, very important thing for you to be able to do actually. How does it look like on a graph? So that would be a very good responsibility for learning question. That shows you're interested, so give yourself a tick for that. Right, so solve that one. Okay. The one that people would make a mistake on, solve 2x squared plus 4x equals 0. Right. So there's two for you to look at.
I have a question.
Okay, how'd you get on with the first one, alright?
No.
No.
I can't understand this.
You factorised it though, yeah?
Yes.
So what did you factorise it to?
Oh, me?
Yeah?
I did x subtract 5 and then x plus 2
Okay.
and then I
So
did
just to make it very, very clear, what you've got there, alright, is that bit now just becomes that. Alright? I've just written it in a different form. I now still have to say that equals 0.
And then I did under it, I did a little a times b.
Okay?
So a times b equals 0, so just so I know. And then I did x subtract 5 equals 0, or x plus 2 equals 0.
Yeah.
And to get 0, x would have to equal 5. And then to get 0 again, x would have to equal negative 2. So then I did...
Well, actually, I think maybe I confused things a bit. No, it's not plus or minus the same number, is it? They're different numbers. So these are my two solutions. That can be it. I've answered the question. So both of those x's, if I only put one of them down, I'd only get half my marks. But I have to say 2. They are my two solutions. Done. What I did do previously is put them into the equation just to check that they do actually give me 0. Now, you wouldn't be expected to do that to give us an answer. It's not part of a full solution. It's just good exam technique, good mathematical technique practice to check your answer works. Because for me, that's why I liked maths and I disliked English as a subject at school. Because I can do my maths and I can check my own solutions more often than not because they work. I can't write an essay or a story in English and decide whether the person marking it likes it or not. I can write it and think, yes, I've met those criteria, but I'm not totally sure. But with maths, especially on ones like this, I can just put my numbers back in and check they work. And I can know if I'm wrong. That's the beauty of it. So that's in my head, that's what I'm doing. So the check is just that. It's my own check. I don't need to write it.
It doesn't equal to 0.
Yeah, it doesn't.
So
Doesn't it?
if you put it into the brackets,
Yes,
you
it
do
does.
2. No, it doesn't.
Yes,
You
it
do
does.
5.
Remember?
5 squared,
No, yeah, 5 squared.
25,
Yeah, and then
minus
negative 15.
15,
Plus 10.
minus 10,
Oh, I wrote plus 10. Maybe that's it.
so it's 0.
Okay,
So it does work.
That equals 0.
Right, how about this second one? Did you start it and decide it was like, oh, don't know what to do there?
Yeah.
Yeah? This one is easier. But people forget about it. That's why I've come to it second. No, it's not the difference of 2 squares because I see why you'd say it's not the difference, and this is not a square and that's not a square. If it was 4x squared, that would be a square, but that's still not a difference and that's not. Yes, Jan?
Do like 2, and then do bracket.
Wouldn't you do 2x?
Thank you.
Oh yeah.
2x.
And then x plus 2. And then
Right. That's fine. Absolutely fine.
but how come you
Do I now have a times b equals 0?
Yes.
A times b equals 0.
But will it work as a quadratic?
Either 2x has to equal 0 or x plus 2 has to equal 0. Now, for 2x's to equal 0, I've actually got a second null factor because a times b equals 0. Now 2 can't be 0, so x has to equal 0.
Whoa.
2 times what makes 0?
0.
0. So x has to equal 0.
That's smart.
X plus 2 equals 0. X has to be
0.
negative 2. Now, I just want to pick out on what Samira did, because it's good, which was actually what she did at this stage, which isn't necessary, but it's good practice, is she spotted that I could actually divide through by 2 first. If I divide everything by 2, I'm not factorising at this stage necessarily, but I am dividing through by a common factor. So a common factor of 2 and 4 is 2. So I'm dividing by 2. So divide by 2, divide by 2, divide by 2. All parts. Now that leaves me with x squared plus 2x equals 0. I'm still at 0 because you divide 0 by anything? 0.
Do we have
So I don't change that. No, I don't have to. But it's something that you may well want to use in the future. Now, I can factorise, and what do I get? X times x plus 2.
No, you're different.
It is different, but what's different? Just the 2.
Yeah.
Because you've divided through by 2.
X still has to equal 0.
X still has to equal 0. Because I've got A
0?
times B equals 0. So it's now even clearer that x just has to equal 0.
So shouldn't it be 0?
Or x plus 2 has to equal 0, which is x is minus 2. Yes?
So do we not like write 0?
What do you mean? Do we not write?
0 squared. Subtract negative. No,
So we can check.
never mind.
Check up here. What's 2 times 0 squared?
0.
Plus 4 times 0 equals
0.
0. So 0 is a solution.
Then how is this?
That means that 0 could be a solution anytime.
No.
Because if you have like.
Because look, that is a good point. Let's discuss.
Actually.
Everyone,
That'd be
is 0 a solution to this one?
0.
Because if I put 0 in, I get minus 10. I don't get 0. So no, 0 is not always a solution.
It's only a solution.
But if you had any other number, but it's like, oh, but there's only like 2, okay. I don't know how to explain this, but if there's always going to be like an x squared plus something x, and that's it, it could always basically be 0.
So if there's no plus or minus at the end, one of the solutions is going to be
X is 0.
0.
Wait,
Yeah.
so one of the x's equals negative 2 though?
Yes, so again, I've got 2 solutions again. X is 0 or x is minus 2. I've still got 2 solutions. Ali? No, because this lesson's about finished. Jen?
Can't you just quadratic it? Can't you just solve it as a quadratic?
We just have.
Yeah, but
That is solving it as a quadratic. Right, that,
then you just be like 2x plus 4 plus 0, and then like do that.
give it a go. Tell me if it works.
It does.
It doesn't, okay. Because
What is like the
I'll give you a different one. One final thing just to think about, because you're all packing up. Those of you that want to head up. Thank you. One final, slightly different one. What would you do if I said x squared minus 16 equals 0? This is the difference of 2 squares. I could do the difference of 2 squares, which would be
X plus 16.
x plus 4, x minus 4.
Like 8 times 0.
However, there's an easier way, which is just rewrite it as add 16 to both sides and get x squared equals 16, which means x is the square root of 16, which is plus and minus 4. Plus and minus 4.
Whoa.
Now this one only works like
16
this
minus 16
because there's no x component in it.
Like no other.
So that's
No
wrong.
other x. No, they're both right.
I get that.
So what if it wasn't a square number?
Because X.
Then it's the square root
Because
of
if
it. I
X
just picked
is
an easy
4,
one.
then 4 is cubed.
Okay, we'll talk about more
X
questions
squared.
next time.